So, hey, welcome to my channel. In this session, today we'll be discussing about heat and temperature. Okay, so basic fundamental stuffs that may be asked that may ask in your competitive examinations. Okay, so we'll not go into the very depth of the concepts, but we'll describe surfacely, which are very much important, and you must know some concepts. Okay, so let's discuss. So before starting the session, I would like to ask you a very one common question. Okay. Okay. So the question says is, I'll just ask you. Like, the question is, mm, the question is, just a second. Okay. Can we change? So this is the question. I would like you to pause the video and just think a bit and then answer if you can. Okay. So if you don't even know the answer, it's no problem. Just try, give it a shot. Okay. So the question says, can we change the temperature of an object without heating? So hope you paused the video and thought a bit. Now I would like to discuss the answer of this question at the very end of this lecture. So stay tuned, and we will be obviously discussing this. Okay. So now let's start with heat and temperature. So heat and temperature are two different things. Okay, so most of people may assume that the heat and temperature are the same thing and they're not any difference, and but actually there is a lot of difference between heat and temperature. Okay, so what is heat? First discuss about heat. So what is heat? So actually heat, let me give you a heading first. So heat. So actually, every atoms of the universe, there are every atoms of the universe possess some sort of motions, right? The universe is comprised of atoms, and these atoms are in continuous motion. Okay, since these atoms are in continuous motion, what is they possess? What kind of energy should they possess? They should probably possess kinetic energy, right? We know, right, when the atoms or particles are in motion, at that time the energy possessed by such particles is kinetic energy. And when they are in positional, when they are in some, there's no motion, they are just sitting in some position, at certain position. In such that it's such thing, the energy possessed by such particles is potential energy. So this is a very basic term. Since here every atoms of the universe are continuously in motion, we might not know how much motion is there, but they are in motions, and since they are in motion, they must possess some sort of energy, and that energy is kinetic energy. Okay, so in simple term, this kinetic energy, since they have some sort of kinetic energy, this kinetic energy measure is what we call is heat, which is nothing but this kinetic energy is modified into thermal energy, what we call thermal energy. So what is heat is actually a thermal energy, which is nothing, which is a kinetic energy, which is possessed by the random motions of atoms. Okay, so this is a very basic definition about heat. But what is temperature then? So what is temperature? So what about temperature? What is temperature? So actually the temperature is just a human sensation. Okay, the temperature is just a human sensation to measure the degree of how hot or cold the body is. It is just the degree of hotness or coldness of body. This has nothing to do with the energy. It's just a measure of hotness, or how hot the body is, or how cold the body is. It is not an energy. It is the thermal state of a physical body. It's a thermal state. It is a thermal state of a body. Okay, it is not an energy, it is a state. In what state the atoms are present, it's a state. And uh, you know temperature is not exchangeable since heat flows. Okay, so it flows, but temperature cannot flow, it doesn't flow. Okay, so we discussed the very basic definitions of heat and temperature. Now we will just make a chart and just write some differences between heat and temperature. It will make our concept more clear. So I'll just make a chart. Okay, I'll just make a chart on heat and temperature. So okay, just using the scales, digital scale. How to remove this? Okay, now in one column we're writing heat, and in another column we'll write temperature. So what is heat? Heat is actually the measure of the energy of an atoms. Okay, this is the measure of energy of an atoms or molecules. It is actually a form of energy. What kind of energy? It is a kinetic energy. So we can simply write it is a form of energy. It is a form of energy. Form of energy. But temperature is not a form of energy. It is not an energy. Not an energy. It is what? It is the measure of degree. No, it is degree of hotness or coldness of a body. And another difference, it is a cause. It is a cause. It is a cause. Rather, it is a effect. It is a effect. The heat causes temperature to change. The amount of energy causes temperature to change. We can see this kinetic energy is directly proportional to temperature. We can have, this is a very much important relation. Okay, you have to remember this, which means if we just increase the temperature of, if we just, what does exactly this temperature means is actually, if we increase the kinetic energy, the temperature also increases, and if we decrease the temperature, then kinetic energy also decreases. So this is a relation between kinetic energy and temperature of a body. And it is found that at 0 Kelvin, it is just a measuring unit. Okay, it is just temperature. We have got a different scales to measure the temperature in an object. It is found that at 0 Kelvin, the kinetic energy stops, the molecular motion stops. The molecular motion of an object stops. So which means it will possess no kinetic energy. That we can say that molecular motion stops. Molecular motion stops. So at this 0 Kelvin, we said this is an absolute zero temperature. Absolute 0 Kelvin. We define this 0 Kelvin as absolute 0 Kelvin, where the molecular motion stops. Okay, so this is a basic things. And let's discuss more about heat and temperature. Actually, heat is measured by using calorimetry. We measure the heat by using calorimetry. We measure the temperature by using thermometer. We'll also be discussing about the scales of thermometers. Okay, thermometer. And what is the unit of heat? Is joule. And what is the unit of temperature? It's Kelvin. Okay, so joule is actually energy, the unit of energy. So Kelvin is just a scale. Okay, it's just a scale. So this is done. We know the basic definitions of heat and temperature, and we also learned some differences between heat and temperature. Now let's get into next topic, and our next topic is different temperature scales. I'll put the heading on with red pen. Temperature scales. What are temperature scales? It's just, I already said, it's just the measure of how the degree, how the hotness or coldness the body is, how much the hot or cold the body is. It's just a measure of degree of hotness or coldness of body. So we just invented some instruments to measure such scales. Okay, so each instrument, every instrument has one scale to measure such things. Okay, so we will be discussing about 4 scales. One is Celsius scales. Celsius scale. Just pardon me for the spelling. Okay, Celsius scale. I'm very weak at spelling. This is Celsius. I think it's yes here. Celsius scales. One is Fahrenheit. Oh my god, what is spelling? And there is Kelvin scales. These are more very important. What is the SI unit? SI unit is Kelvin scale. Okay, so Celsius, it is a what? SI unit, Kelvin scale. So how do we define these scales? Actually, we define these scales as, so let me make you a quick reference thermometer. So there is a thermometer. I'll just making a reference thermometer. Okay, and let's say this is a thermometer. Looks like it's something else, but still let's consider this is a thermometer. Okay, so there is some liquid. So we are talking about old days thermometer, not new days. Nowadays the thermometers are very digital, right? Every thermometer is digital, but in previous days there used to be some liquids over there, over here. What happened to the brightness? Some liquid over there, and the expansion of this liquid helps to measure and there is also some scales over here. Okay, so there is like 0 degrees Celsius, so 0. Okay, so 15, 20. So this is some numbers are over there, and the liquid that is in this is called thermometric liquid. Some liquids are used here. So let's also discuss about this liquid. Okay, so there are majorly 2 liquids that we should know. Okay, so first one is mercury, and the freezing point of mercury is minus 30 degrees Celsius and the boiling point of this mercury is 300. You don't need to remember the data. Okay, and there is also alcohol is used as a liquid material. If the alcohol is used, the alcohol freezing point is minus 115 degrees Celsius, whereas its boiling point is only 45 degrees Celsius. And under what conditions which liquid has to be used, you might have probably the idea, right? Since its boiling point is so high, right? So it is used in some high temperature. It is used in measure high temperature. Measure high temperatures. It is used to measure high temperature since it has got very high, boiling point. So we can use it. We can use it to measure high temperature since it has got very low freezing point. So we can measure as much as cold temperature. So we use this alcohol in the thermometer to measure low temperature. Right? You probably got the concepts. Right? You don't need to remember these values. Okay, so this is of no use. Now, let's say in Celsius scale, how do we define the scale? Now, we define a scale. We just define a scale with a formula, and the very basic formula, fundamental formula is, let's say x is a scale. Okay, so x is a scale. We x minus so upper fixed point. Okay, upper fixed point. Sorry, this is no upper fixed point. This is lower fixed point. So x minus lower fixed point. Lower fixed point, what do you mean by lower fixed point? Lower fixed point, if this is a thermometer, how much low, a thermometer can be. Suppose this is lower, suppose this is low scale a thermometer can measure. So this is lower fixed point. And the upper fixed point, how high the thermometer can measure. Okay, so it's the upper fixed point. Thermometer means how high can this actually liquid expand. We can know this. So I'm denoting this lower fixed point as LFP and upper fixed point is UF fixed point P. Okay, so we define this scale as a scale. This is a scale. Okay, so x is a scale. How do we define scale? We define scale by using formula such that x minus it's the thermometric liquid lower fixed point upon upper fixed point minus lower fixed point equals the another scale, let's say y, same minus its own lower fixed point upon its own upper fixed point minus lower fixed point, and it goes continue and continue, can equal to, and how many, this is how a scale is defined. Okay, so a Celsius scale is defined as, okay, so a Celsius scale is defined as C. Okay, we used now Celsius scale, so X is replaced with C. C minus, in Celsius scale, lower fixed point is 0 upon upper fixed point is 100, which is a boiling point of water, and lower fixed point is what is 0, right, equals, now Fahrenheit scale is minus F minus 32 is lower fixed point, and upper fixed point is 212 minus, and lower fixed point is, what is lower fixed point, 32. And in Kelvin scale, we define Kelvin scale as K minus 373 minus 373 minus 273. So this is a basic conversion. This is very important in numericals, you have to remember this. Okay, so now if we just simplify, then it comes out to be C minus 100 equals to F minus 32 upon 180 minus equals K minus 370. No, this is 273, right? This has to be 270 because lower fixed point, not upper fixed point. So lower upper fixed point, so lower fixed 273 minus is 100. Okay, so this is also has to be remembered. This is just a simplified version of this. But in competitive examination, we don't use this long formula. We definitely remember this concept. We have to remember this concept, but we don't use this formula while solving questions because it will take a long time. So I'll just make a simple formula for if I'll just make some formula list. Okay, so we just write it in Celsius scales. If Celsius equals 5.9 Fahrenheit scale minus 32. This is just a modification by solving this equation. This will come out. Why? Because in competitive exam we have to make things in a very easy way. So this is and also change in Celsius scale is equal to 5/9 and change in Fahrenheit scale. We'll do questions on this topic. Okay, no need to worry about this now. Next thing we have to remember is, so I think this is the only thing that, and also the change in Celsius scale equals to change in Kelvin scale. So it will become equal. And if we want to convert, Celsius into Fahrenheit, then we'll just add, just Fahrenheit, where's pen? Fahrenheit scale equals to Celsius plus 273. Okay. So these are the formula. These are 4 formulas that we to remember. This will make our work more easier. So this is what we could discuss up till now. Okay, so heat and temperature is done. Celsius is done. The questions are asked from this box. Okay. Most of the questions are from this box. We also discussed temperature scales. Now let's talk about amount of heat. How do we calculate the amount of heat? Where the most of the numericals questions are asked from this topic. Okay, so let's talk about heat. Right now I'm talking here. Okay, heat. So how do we measure heat? We simply measure heat by the formula. I'm not going to derive the formula because there's no use. Okay, so we derive it. I must change them. So what is Q? Q is the amount of heat. M is the mass of liquid, how much gram of liquid is, or what is the mass of object, whatever the object is, not liquid, that may be liquid, solid, gas, whatever. Okay, object. So this is a specific capacity. We'll be discussing this specific about in more detail. Specific heat capacity, and this is change in temperature. This is delta sign. Okay, so this is change in temperature. Let's discuss about this specific heat capacity first. So what is specific heat capacity? Let's just define it. Specific heat capacity, when you just simplify this equation, it comes out to be specific heat capacity equals Q upon M change in temperature. So how do we define this? It is the amount of heat. Okay, so it is the amount of heat which is required to raise the temperature of 1 kg mass by 1 degree Celsius. So this is what is specific heat capacity. we defined it. And this specific capacity neither depends upon this, nor it depends upon this mass, also not depends upon temperature. What does this depend on? It actually depends on material of an object. It's actually every object has its own specific heat. Okay, so it doesn't depend on amount of heat, how much. It also doesn't depend on mass, or neither it depends on change in temperature. What does it depends on is actually the material of object. It doesn't depend on these things. Okay, so this is very important. So we have to know the specific heat capacity of water. Specific heat capacity is 4200 in joule, and also 1 calorie in another scale. And 1 joule equals to, sorry, 1 calorie equals 4.12 joule. So this is also a conversion unit. Okay, now so we discussed about specific heat capacity, and there are many reasoning questions that can be asked from this topic. I mean, this if what does it mean when the specific heat capacity of object is high? That just simply means the amount of heat required to raise the temperature of a body by 1 degree Celsius is high. This is this is actually a practical concept rather than theoretical concept. So this is very much important about specific capacity. So this is one formula we discussed. Now let's talk about latent heat. We talked about specific heat. Now we talk about latent heat. So let's talk about latent heat. Latent heat. It's actually generated by L. Okay. So what is latent heat? It's a very beautiful concept, So let's say there's a vapor, water vapor. So let's say there's a water vapor. If I cool the water vapor, it becomes what? Steam. Right? If I again cool the steam, then it becomes what? What it becomes? The temperature decreases, right? So no, let me just explain this writing temperature. So this is a water vapor. If this is a water vapor at 100 degree, if I cool, then it becomes steam at 100 degree, right? Obviously, right? So if I again cool this steam, then it becomes water, which is at 0 degree Celsius. And if I again cool this water, it will become ice at 0 degree Celsius. What can we see here is, this is actually, we are supplying some heat. I mean, the cooling is also heating, cooling is also changing in energy, right? It's energy. Cooling is actually we're withdrawing energy.